Welcome once more to our video tutorial. My name is Chigomana David. At this point in time, we're going to look at topic 2 of level 3 principles of computer programming. Now, the topic's title is Program Development Environment. Now, different data types are suited for different applications, and therefore all data types are stored or represented in the computer in different ways, but all are stored in binary form. Let me repeat this for the sake of effect. All data types are stored or represented in the computer in different ways, but all are stored in binary form. Number conversion techniques. Data types. Now we have the following data types. We have the integer, e.g. 10, 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have real or single, which are decimal numbers. We have double, which are numeric floating point, e.g. 23.45666. We have string, which can be single or a number of string, e.g. hello, b, c, etc. Variables. Variables are named areas of the computer's memory. So in order for the computer to know variables, a programmer has to declare them. Now, what is the meaning of this? It means that if a variable is used before it has been declared, therefore the computer won't know about it. Therefore, in order for the computer to know variables, a programmer has to declare them. Now, data type declaration. There are two ways of declaring variables: an implicit declaration as well as explicit declaration. Now, let me describe the two types of declaration. Explicit declaration means to define a variable in a clear and detailed way, including the data type of the variable, whereas implicit means to define a variable by specifying a name only, so that a data type is implied or indirect. This is not recommended. Let me repeat this. Explicit means to define a variable in a clear and detailed way, including the data type of the variable. Implicit means to define a variable by specifying a name only, so that a data type is implied or indirect. This is not recommended. Now, where do we declare variables? We declare variables on a compiler. Now, when we say open Visual Basics or any programming language, where you are busy typing in your code, that is what we call a compiler. Now, we declare variables on a compiler. Now, when you type your code, you are typing in English, but the compiler turns what you write in a language the computer can understand. Integers. Now, integers is a set of all whole numbers, including positive and negative numbers. Integers vary in bit length. The bit length determines how big an integer value can be. Single precision numbers. Now, these are what we call real numbers. Now, the accuracy of a single precision value depends on the computer language, but it usually is 7 significant digits, e.g. 34,332,000,000, etc. That is a 7 significant digit. Now, the above number has 5 significant digits. Double precision numbers. Now, double precision numbers are similar to single precision numbers, but twice as accurate. Let me repeat this for the sake of effect. Double precision numbers are similar to single precision numbers, but twice as accurate. Number conversion between different data types. Now, all programming languages have functions to enable you to convert from one data type to another. Let me repeat this for the sake of effect. All programming languages have functions to enable you to convert from one data type to another. Let us relook at implicit type conversion. Now, this will be done automatically by the computer. Now, for example, deem f number as integer, deem s number as single. F number is equals to s number divided by 5. Note that some languages truncate numbers. Now, what is to truncate? Now, to truncate means to chop off some numbers, e.g. 680.85, and then the answer becomes 681. That is to truncate. Let me repeat this. Implicit type conversion is like dim f number as integer, dim s number as single. In other words, that is implicit type conversion. Note that some languages truncate numbers, and to truncate means to chop off some numbers, e.g. 680.85, and the answer is 681. Explicit type conversion. Now, here as a programmer, you have to put a method in place to be able to make this conversion. In other words, when we talk of explicit type conversion, here as a programmer, you have to put a method in place to be able to make this conversion. E.g., int number is equals to cint into txt number.text. In other words, whatever is inside the text box is going to be converted by using the conversion method, that is convert to integer, which is cint. There are many conversion methods that you can use, and that is what we call explicit type conversion. Now, what happens when you try to convert a string that does not contain a valid number into a numeric data type? Let me repeat this. Now, what happens when you try to convert a string that does not contain a valid number into a numeric data type? The answer is you get what we call runtime error. Now, what is a runtime error? A runtime error is an error that is only generated when the program is running. Now, what is it that we can say about this? In other words, when we talk of runtime error, that is an error that is only generated when the program is running. In other words, you won't see it while you are still busy, programming. But that runtime error will be visible when you run your program. Logical variables and their uses. Now, logical data types are also known as Boolean data types. They can only have two values, that is true or false, yes or no, yeah or nay, etc. Flag variables. Now, logical variables are often used as flags. Now, what are the functions of a flag variable? The functions of a flag variable is to store the results of a logical expression. Let me repeat this for the sake of effect. Flag variables, logical variables are often used as flags. Now, the functions of a flag variables to store the results of a logical expression. Logical operators, and, or, and, not. Internal representation of numbers. Let us start with signed numbers. Now, a signed number is the one that can have either a positive or a negative number. Integers. Integers are usually represented as string of binary bits. Floating point numbers, e.g. 2.341455 multiplied by 10 to the power 11. Note the following. The storage space is divided into three parts. That is the sign, the significand, and the exponent. Let me repeat this for the sake of effect. The floating point number storage space is usually divided into three parts. We have the sign, the significand, and the exponent. Single precision. Single precision are stored as sign, significand, and exponent. Let me repeat this for the sake of effect. A single precision number is stored as sign, significand, and exponent. Characters. Each character, normal and special, is represented in a computer by a binary byte. Let me repeat this for the sake of effect. Each character, normal and special, is represented in a computer by a binary byte. Arrays. Now, these are table of dimension numbers or characters stored in the computer's RAM. Arrays can have one or more dimensions. Each element in the array is referred to as an index. An index is the position of an element in an array. Arrays are represented internally as pointers. Let me repeat this for the sake of effect. Arrays are tables of dimension numbers or characters stored in the computer's RAM. Arrays can have one or more dimensions. Each element in the array is referred to as an index. Index is the position of an element in an array. Arrays are represented internally as pointers. Now, what are pointers? Pointers are like arrays, but they don't contain data, and they have information as to where the data is stored. Let me repeat this point about pointers. Pointers are like arrays, but they don't contain data, and they have information as to where the data is stored. Pointers are more powerful than simple arrays or indices, especially when used with character information. High-level programming language concepts. Now, the following are what we call high-level programming languages concepts: constants and variables. Now, computers make use of constants and variables to store data. Explanation of each concept. Let us start with variables. A variable is a placeholder in memory that can change during the execution of the program. Let me repeat this for the sake of effect. A variable is a placeholder in memory that can change during the execution of the program. A constant is the value right, I'm sorry about that. A constant, okay, I'm sorry about that. The value in a constant is fixed or constant. In other words, the value in a constant will never change during the execution of the program. Let me repeat this for the sake of effect. A constant, when we talk about the constant, that is the value which is fixed or is constant. Note that the constant is declared with the word const instead of the word dim. Constants are declared with the word const instead of the word dim. Right, let us look at the concept or let us look at the right, let us look at the concept of operators in expression. Right. Now, the following are the operators that we are going to look at. Right, we have this one, which is addition. Right, we have this one, which is subtraction. Right, we also have this one, which is multiplication. Right, we also have this one, which is division. Right, we also have this one, which is equal sign. Now, there are some of the things that I just want to mention here. This one in programming, we use the star. The division, we use this one. Right, when it comes to the equal sign, right, an equal sign can also be referred to as an assignment. It can also be referred to as an assignment operator. For example, if you write something like A is equals to B, here equal sign is used as an assignment operator. In other words, the content of B is assigned to A. Right, operator precedence. Operator precedence use what we call BODMAS. In other words, BODMAS stands for brackets of D for division, M for multiplication, and A for addition, as well as subtraction. Alright, now let me just give you an example here. We have an example like this one. 2 plus 5 into 2 plus 10 minus 2. Right, according to BODMAS, we're going to start by removing the brackets. We're going to have 5, 2 plus 10 is 12, then minus 2, then we're going to have 2, 5 into 12, this one is going to be 60 minus 2. Then we have 62 minus 2, then the answer is 60. Right, let's say for example we have something like this, 2 plus 3 plus 2 minus 3. Right, the first thing is it's gonna be that we have to work our brackets out. Right, we are going to have 5 plus minus 1 is 5, positive times negative is minus 1, and then we have 4. That is what we call operator precedence. Right, I'm going to give you an example here. Let's say for example we have something like this, true or false or true. Here we are going to use the principles of binary. In other words, it's brackets. We have not, and then we have and then we have or. So which means in this case we are going to ask ourselves, for this statement, do we have brackets? No. Do we have not? No. Do we have and? No. Do we have or? Yes. Therefore now you can say true or false. The answer is true, and then true or true, the answer is true. Alright, let us continue. Now let us say for example we have 5 greater than 7, and we have something like that, and then 2 less than 1. Right, 5 greater than 7, the answer is, the answer is false. Right, the answer is false. And then we're going to have and 2 is greater than 1, the answer is false. False and false. Right, the answer is false. Right, we also have 2 less than 1 or 1 less than 2 and 1 greater than 2. Right, we first remove the brackets. 2 is 2 less than 1, the answer is false. Or is 1 greater than 2, the answer is false. And is 1 greater than 2, the answer is false. Right, we have F or F and F. So according to the principles of binary, we start with and. F and N, F is F or F, the answer is F. Right, basically that is what I wanted to tell you. Right, let us continue evaluating expression, further examples. Let us try to evaluate further examples. Let's say for example we have 2 plus 5, 2 plus 5 is greater than 1, and 3 plus 2 is greater than 1. Right, 2 plus 5 is 7, which is 7 greater than 1, and then we have and, which is 5 greater than 1. This one is true, and this one is true. Right, which means after evaluating the expression we have true. Right, we are going to have something like this, 2 greater than 5 and 3 less than 1, or 2 greater than 1. Right, the first thing will be to put these things in brackets. right? You put these things in brackets. Is 2 greater than 5? The answer is false. And 3 greater than 1? The answer is true. Or 2 greater than 1? The answer is true, right? According to the principles of binary, according to the principles of binary, we're going to start with and f and t. The answer is t, or t. The answer is t, right? Basically, that is what I had for you. Now let us go and look at what we call modular programming. Right, modular programming is the process of dividing up a large programming project into smaller modules or procedures. Let me repeat this for the sake of effect. Modular programming, this is the process of dividing up a large programming project into smaller modules or procedures. Now, advantages of modular programming. Now, modular programming makes the program to be small so that it can be managed. Programs are divided into modules that are easier to work with. Small modules can be reused, thus avoiding unnecessary work. Now, Visual Basics allows two kinds of subroutines modules. In other words, in Visual Basics, we have two kinds of modules. We have the sub-procedures as well as the functions. Explanation. Now, a function is a special procedure which returns only one value. And a sub-procedure, this one does not return any value. Sometimes functions and procedures use parameters. Now, parameters are also called arguments. These are variables which are used by a function or a procedure. Now, when do we use the word parameters and when do we use the word argument? This can be explained as follows. In the function itself, we use the word parameter, but in the calling statement, we use right. Let us look at repeat application development. Now, here we have to explain the concept of repeat application development. Now, this is a method of developing computer systems in a relatively short space of time. Programs nowadays depend much on using the mouse or keyboard. These programs are event-driven. Now, event-driven is a way of programming in which the flow of logic in the program is decided by the events outside the program rather than by the programmer. Now, let me repeat this for the sake of effect. Programs nowadays depend much on using the mouse or keyboard. These programs are event-driven. Now, event-driven is a way of programming in which the flow of logic in the program is decided by the events outside the program rather than by the programmer. Right, let us come to the explanation of visual programming and its usage. Now, visual programming, also called VPL in short, usually describes a programming language that uses visual representation to do what would otherwise be done by a conventional text-based method. These programs usually makes use of IDE. Now, what is an IDE? IDE stands for Integrated Development Environment. IDE usually consists of a source code, a compiler, and a debugger. In other words, where you write your code, it's your IDE. In short, IDE stands for Integrated Development Environment. That is the end of our lesson. Let us meet next time. May God bless you. Thank you.